and welcome back to a new video here on the Lötwig Fusel channel. In this video series C++ libraries, we're going to explore a new C++ library every week. Now in this week we're going to take a look at googletest, or also commonly called gtest. Googletest is a unit testing framework that has many features, and I would highly recommend using if you want to go for unit testing. Now unit testing in general, the idea behind unit testing is that you're going to write some code that verifies your library code. So if you're writing a library and you're providing several features in the library, you're also going to write an additional software piece which is called the unit test, and the unit test is going to validate that your library runs correctly. So the idea is, if you're writing a new part or updating a part of your library, you make sure that all edge cases and possibilities that can go wrong with the code are kind of catched by a unit test, which basically operates your code. So if you have a container, a linked list, then your unit test is going to insert items into the linked list and going to make sure that it can retrieve the items, that if it inserts pointers, that the pointers are not altered, or if it inserts elements, that the elements are not altered, that everything kind of works correctly with your piece of code. And yeah, it basically has a set of functions that it's going to call. It's called the library, and it's then going to verify that everything is correct. And the idea is, if everything is going to change, for example, you have a class that does memory allocation, you change the memory allocation class, the unit test for the memory allocation class succeeds. However, in some other place in the code, somebody has abused the memory allocator and was always expecting that the memory allocator returns at least 10 bytes more than it requested, or any other issue that might arise. Maybe memory allocation is not the best example here, but you kind of get the point, right? Somebody has assumed that the code works as it is, even if it kind of maybe was a bug that somebody else used. So you fix the bug in your code, and somebody else's code is going to break, and that's a problem. So you need to have a way to kind of check that this is not going to happen, and this is why you need to provide unit tests. Unit tests are basically instrumenting all the pieces of your software, and if one change in one piece is breaking another piece of your software, the unit test is then going to show an alert and say, oh, hey, there's something wrong. This is something where you need to do a bit of research. And then you can do the research in it, and you see what's going wrong, and then you can fix it, and everybody's happy because your software is on a good quality. And unit testing is also used for CI. So every big library on earth has CI implemented, and if you want to make a pull request to this library, the unit test of the library needs to succeed, or the pull request will not be merged. Same here for googletest itself. Googletest itself has pull requests, and you can see these little check marks or X boxes here, and if you get an X, it means that some check has failed. And what this check could be, for example, a unit test that fails. I don't know what it is. If I would open this up, I might see what it is. It's probably... yeah, there you go. It is CI at Windows. So you can see that on Linux and Mac, everything compiled and the unit tests were successfully, but on Windows it failed. And if I would go even deeper, you can see that actually the unit test failed here in this case. You can see there are multiple parts to that. Everything has a check. The only check on Windows that failed, for example, was this thing called tests, which is the unit test. And if I would maybe take a look at this, you can see, okay, failed. Build did not complete successfully. So it was actually before the unit test was even executed, so it's a bad example, but in general you kind of get the point, right? The unit test could fail at a certain thing, and then you can see what's going wrong. Alright, so now let's start using googletest. Now how can we use googletest? Well, you can use it however you like. I'm gonna use it with Conan because that's how I roll, how I do it. So I'm gonna copy myself this Conan idea here, and I'm gonna go to my moxpp template. I prepared an empty moxpp template that hasn't any changes applied to it. Moxpp is my GitHub template repository that incorporates the Conan packet manager and the pre-make build system. Additionally, a few scripts that make everything a bit easier to use. Now, first of all, what I'm gonna do is I'm gonna change the dummy SPD log to googletest, and then I would be ready to execute and generate my solution, my Visual Studio solution. However, there's one more thing that we need to be concerned about. The thing that we need to concern about is a main function. Now, this sounds a bit odd because we are not even in code yet, but the problem is that gtest by default always generates a main function by itself. So by default, every project that is going to include googletest might have a main function attached to it. And the way MoxPP works is that MoxPP automatically detects dependencies of the libraries and adds them to all project. And this is in this case bad, because in this case it automatically also adds the main function generated by googletest to all projects. However, this is not just MoxPP that has issues. I know many people that have issues with that and don't like it. This is because, yeah, really a main function shouldn't be provided by a library. It's just kind of like also a bit of philosophy. However, what you can do is you can tell gtest to not include the main function, and if you go back to Conan and go to the recipe, you can see many options that are available for gtest, and you can see that there's an option called no main that can be true or false. So this is what we want to do. We want to set no main to true, because by default no main is false, and this is going to make sure that no main function is generated. Now, how do we set this to true? Well, it's very simple. We need to go to the options of gtest, and instead of wchar support, we're going to provide no main, and we set it to true. And now everything is okay. We can remove the pass, and now we have configured googletest to not include a main function. Now, if you are downloading it differently, this might be more complicated to do than just adding this one line in Python, but that's why I use my template. So let's run mox init. This is going to initialize the project. And you can see that it runs a few actions. Now it's finished. And yeah, I completely forgot to change stuff. I need normally what I would have done is I would have gone into mox.lua, changed the product name, and I would have gone to build.lua and changed it away from hello world. But it's okay. Maybe we can work with a hello world project today. So let's go to moxpp.sln now. You should name it definitely better, but it works, right? We have gtest, and that's everything that we need. Let's click here and open up the main file, and let's also remove the default content and the default include, and now we are ready with a very, very simple main function. Now, the first thing that I want to make sure is I want to make sure that googletest is called, because I told you that googletest by default generates a main, but we have told it to not generate this main, so we need to manually implement it. How do we implement that? Well, first of all, gtest, this is what we need. Then we need argc and char pointer argv, and now we have everything to correctly initialize googletest with all of the arguments. So the namespace of googletest is called testing. So no, testing. There we go. Testing. So that's the namespace that I want to go into. And inside of the testing namespace, there is a init googletest function, which takes a pointer to argc and a pointer to argv, or pointer argv. So argc pointer and argv. I don't know why argc is a pointer, but yeah. Now, this is basically the call to initialize googletest. This is used to make sure that googletest is set up correctly and that we can use it. Now, what we need to do is we need to actually run these, and we run them by calling a function called run all tests. This is a global function. gtest has many global functions available. Not all are inside the testing namespace, but in this case, we want to call that one the run all tests. That is gonna then actually call something called testing unit test get instance run, which is a bit long to write, but it is C++ in general. And what it's going to do is it is going to execute googletest and give us the return value that googletest suggested. Now, this is the boilerplate code. It's not much that you need to write, so it's totally fine to do it manually. And if we run that, we should already be presented by default gtest. And that is default gtest running 0 tests from 0 test suits, 0 tests from 0 test suits run, 0 tests passed, everything is green because there were no tests, return code 0, all good. Now, what we want to do is, of course, we want to write our own unit test. Now, how do we write a unit test? Well, we use the test macro. The test macro is a macro that's required to kind of like generate this test, inject this properly. If I hover over that, you can see that it is really going nuts and doing stuff. It is a madness, but that's everything that's required. That's okay. Now, the only thing that we need to supply now is we need to supply a name of a test suite and the name of the test. So I'm going to call this one example 1 because it's our first example. And in our first example, it's the first test. So example 1, test 1. So what could we test? Well, we could test if, for example, we are using strings that are null terminated. So const char abc. Oh, let's call this one test string, and the test string is ABC. Now, what we want to do inside of the test, we want to assert something. We want to assert equal. So we want to assert if something is equal. And what we want to assert is that string length of test string is 3, so that we have a 3-character test. And what we also want to assert is that we want to assert equal that test string at position 4, or actually it's position 3, that it is equal to the null terminator. These are the two assertions that we want to do. We want to make sure that the string length returns ourselves the length of 3, so the actual numbers of characters, and the test string at position 3 is the null terminator. And that's actually everything that we can do. We can press F5 and the unit test is automatically registered, executed, and shown on the console. So you can see running one test from one test suite, example 1.test, run, okay, everything is good. How can we make that fail? Well, we could make this fail by adding a dash in here, because the dash is kind of like wrong in there and it all does everything. And if you can see, as you can see, if I add the dash in here, expected equality of these values, string length test string, which is 4, and the value accepted here was 3. So you can see 3 is the value it should be, it was 4, something goes wrong, and string length of the test string was what has gone wrong. Now what you can do is you can provide custom hints for that and say the default test string is always 3 chars long. And for example down here what I can provide is strings need to be null terminated. And as you can see, if I add these messages and press F5, you're also gonna get them. Here, the default test string is always 3 chars long. So I could make it 3 chars long, like that, and everything is good. And I get, succeeding unit tests again. Of course, I could do and alter something. For example, what I could do is I could very sneakily kill myself the null terminator, even if there's no point in it. And I'm actually even not allowed to that. I would need to do it like that. No, I think you should get the point what's going on. Of course, in reality, you need to make a few more interesting tests on that. All right. So let's go into a bit more advanced tests. Let's go into so-called test fixtures. Now a test fixture is basically a kind of like template test that then gets multiple tests executing on it. So what you can write is you can write yourself a class called this like my test fixture here, which is a public testing test. That's kind of like the base class. And what you can then do inside of the protected arguments is you can provide several things that need to be done. For example, what I could do is I could use a vector to kind of like validate that my data is good in a vector. So, right, let's do a vector. And what you can do is you can kind of like provide an std vector in here. Let's maybe put integers in here. Let's call this one tvec for test vector. And what you can then do, for example, if you're writing now a test, you can write a test based on the fixture, my test fixture, and let's call this one item count, because we want to check that the item counts are done correctly. And what I can then do is I can do like tvec pushback 1 and 2, and then I can do assert equal, and I can assert equal tvec size, and I want to have 2 items in here because these 2 items shall be in here. So you can see if I kind of like write a class, I kind of like fixture, a test fixture based on the test here, and use it in the fixtured version, you can see that I can use everything that's inside of the class because this is basically inserted into the class. Or it's kind of like a super class building on top of that. And if I run that, running one test from my test fixture, item count was successfully. It seems to not work anymore, but yeah, it's all good. Now, one thing that you can do here as well is you can provide so-called setup and teardown functions. Setup and teardown is very useful, for example, to kind of like always have like a generic test vector, right? The my test fixture by default should have already items in here. So what I can provide is I can provide a void setup. You can see it's already in here, and I can override it, and I can provide the setup function in here. So what I can do is kind of like, yeah, let's insert a few items here. Let's insert from 1 to 9, and then I can say like tvec pushback, and then I can push back I. And then what I would have is, always when the unit test is executed, it would call setup, it would create like a new instance, it calls setup, and then it runs the unit test. So in this case, this shall no longer work. I should have like now 12 items in here. So you can see, right, tvec size, which was 12, but I expected 2. Well, because I've pushed back 2 items in here. However, that's not what I want to do. I want to verify that my 10 items are in here, so that they are kind of like correctly in there, and if I do it, everything is good. Now the nice thing with test fixtures is that they are reusable. I can write another test on that fixture, and I can call this one like item state. So I want to verify that the state of my items are okay. So what I could do is I could write a for loop in here for auto reference e in tvec. So for like all of my ints, I would have an int expected, or let's call this one x, because the expected value is 0, and then I can assert equal e expected, or I could even use like post increment to automatically increment through here. And this is now basically kind of like resolving my fixture pattern. The fixture has set it up the class, makes sure that it was initialized correctly, and now I basically have 2 unit tests. One checks the item count and one checks the state, so that the state of the item is correct. And if I run that, I should get like these 2 tests been running successfully. However, if I would now think that my items like start at 1 and go to 10, or this is kind of like my recommendation, then you can see that the unit test will fail. E is 0, XPP is 1, so there's an issue in here, and the unit test failed again, which I could of course solve by just putting that to 1. But then I would say like smaller equal. And if I do it like that, and if I run it, I gotta get again working unit tests. And that's actually everything that I want to show you here with the tests inside of Visual Studio. However, I want to show you one more thing. I want to show you how you can instrumentalize that. So if I go to my gtest folder that I have created today, and I go to my build directory, to my debug directory, to my binary directory, we have the hello world.exe. If I open up a cmd and run my hello world, you're gonna get my unit test. However, the nice thing with gtest is that it also has command line arguments. So if I do --help, you can see that I'm not going to get my test output, I'm going to get a usage of it. Now what you can do is you can list all tests that are available, you can filter so that only the tests that you want to kind of like execute is executed. You can run tests that are disabled, so instead of gtest you can disable tests. Now not really how, could look this up in the documentation, but you can kind of like force these. You can run tests repetitively or run them forever. You can shuffle the order of the tests to make sure that your library is maybe even robust in kind of like out of order usage. You can say if you want to use color, if you only want to print failures, if you want to print the time for the tests. If you want to output this to a file, for example, to JSON or XML, you can do this as well. And you can also say like break on failure, turn assertion failures into debugger breakpoints, turn assertion failure into C++ exceptions for use by an external test framework. Do not report exceptions as test failures, instead allow them to crash the program or throw a pop-up on Windows. So you have many options that you can do, right? So let's see. For example, what would be really helpful is to kind of like get a feedback how your tests were executed. So how was it called? gtest underscore output. So gtest underscore output, and I could, for example, output to XML. Or I could output to JSON. You can see it doesn't really make any difference when executing the unit tests. However, if I go inside of Visual Studio Code and take a look at my directory, you can see that I have testdetails.xml and testdetails.json. If I would open up the testdetail.xml, you can actually see a few informations about the tests that were executed, right? The general test suite said that we had like 3 tests, whatever was executed here, no disabled, no errors, timestamps, and name. all tests in this case. Then you can see that we have the test suite example 1 and the test suite my test fixture. You can see that example 1 had a test called test 1 that was completed, and there are no failures in here. Down here you can see the same for item count and item state into my test fixture. JSON is a bit more blown up and complicated, however it is including the same information. Now if I would make a test fail, we can do that, for example, by putting that back to 0, which should actually make both tests fail, and build it. We should get a few more information on what can go wrong. Let's run it again in XML because I like the XML stuff. You can see that these 2 tests have actually failed, which also gives us a total of 2 failed tests. And if I would now inspect the details here in Visual Studio Code, you can see that we have a failure here. And you can see that we have a message encoded with also new lines in here, which is not 100% clean, but I think for like XML it is actually valid to do like that, so it is okay. You can see that actually we have also the color information encoded in here, so we would maybe even run this without color to not have color included in here. You can see that we have a failure, so yeah, there are many things that are now encoded in here and really give us information on what has gone wrong in here. And JSON is doing really the same thing, right? JSON also to failing. Now JSON is encoding them a bit better. The failure on JSON is because JSON, I think, can't handle new lines, is encoded properly and without color codes. But yeah, this is really nice, right? You can get so many insights on how your test went wrong. Okay, so this concludes the video. Thank you for watching. I hope I was able to show you a bit on how Google Test works and maybe encourage you to use unit tests, because it is darn simple and darn powerful to use a unit testing library and have several kind of like usages that can be done there. So it's really easy, nice, and only brings benefit. So thank you for watching. Make sure to like and subscribe, and have a nice day. Bye.